Alrighty, page 9. That's right. We're going to first start with dividing both sides by 2. Why? Because we can. So this becomes the ln of x is equal to 2 ln 3. And we're going to rewrite this one. I don't know if you remember, but when you got the power to a power, it's like the come on down power. So the Price is Right, come on down. But we're going to go on back. So it's ln of x is equal to the ln of 3 squared. And that refers back to your come on down property, which is the powering property, which is the top of page 7. Now that I have 2 logs of the same base, which are natural logs, I can tell you that the x equals the 3 squared. And I just solved 3 squared, and that's going to give me 9. And that's going to be fine if I put it back in there. So far, so good? So when you do that powering property on page 7, you'll see where that comes from.
So because you have
we call this
ln on both sides, you can just cancel those out.
Because it's log base e, both sides.
Okay.
Right. It's hard to call it canceling. It's kind of like, you know how we square root both sides?
Yeah.
Right? We're kind of de-logging both sides.
Or like dividing both sides.
You could take the log of both sides if you wanted to. You could de-log both sides. We just de-logged it.
All right.
Okay? All right, let's look at our next example. Log base 4 of x minus log base 4 of 3 minus x equals log base something
5
of 25. Okay, now I can combine these using the this subtraction means you do the division. Okay, and since the log bases are the same, that's totally cool. So this is going to look like log of base 4 of x over 3 minus x. Now on this side, I'm going to go ahead and do a little bit of rewriting. I'm going to make it look like log base 5, and how else could I write 25? Can I write it with a base of 5?
5 squared.
5 squared, that's going to help. So far so good? Okay. Just to kind of write off on the side, this is going to be the same thing as that 2, Price is Right. Come on down. You're the next contestant. So what is log base 5 of 5? It is 1. So that's going to be 2 times 1, so that makes that side equal to 2. Would you agree with that? Now, the x's are here in the middle. Do you see that? And I have it in logarithmic form. If my x is in the middle and I'm in logarithmic form, what I really want to do is put it in exponential form. So we're going to do a lean to it at this point. We're going to lean to the left. What do we see? 4. We're going to lean to the right. What do we see? 2. It equals the middle. And so 4 squared is 16 equals x over 3 minus x. I mean, there's a couple different ways to do this. You could set it over 1 and cross multiply like we did before. I'm going to erase this part over here so I can continue. So I'm going to end up with 16 times 3 minus x equals x. So 48 minus 16x equals x. I'll add 16 to both sides. Excuse me, 16x to both sides. 17x equals 48. I'll divide both sides by 17. I end up with 48 17ths. And 17 times 3 would be 51, right? And so this number is less than 3, so this would still be a positive in here, so you should be good to go. All right? I am on. Okay, so we have log of 5 plus x plus log of 2 plus log of x. Now, what can you tell me about the bases here?
A unique equals log of x.
Equals log x.
The bases are all the same.
Bases are the same, and what are they? They're all 10, even though we can't see them. When I have this addition here, that's the same as multiplying this, so it's going to look like log of 5 plus x times 2 equals log of x. Now here I have logs that are the same base. So when I have log of m equals log of n, then I know m equals n, so I know that this 2 times, excuse me, that should have been a 5 plus x. 2 times 5 plus x equals x. So this is going to give me 10 plus 2x equals x. If I subtract 2x from both sides, 10 equals negative x, divide both sides by negative 1, I get x equals negative 10. Now, is there a problem with that?
Yeah.
Yeah.
There must be no solution, I'm guessing.
That is right. You cannot take the log of a negative number, therefore no solution.